Scientists claim in their controversial paper that satellite megaconstellations like SpaceX's could weaken Earth's magnetic field and cause atmospheric stripping. Should we be worried? We know that Earth's magnetic field is weakening anyway, and this, because of the megaconstellations, could become even more of a problem. A theoretical new paper argues that atmospheric metal pollution from falling space junk could create an invisible conductive shield around our planet that might weaken our magnetosphere. However, other experts are skeptical of this idea. Spacecraft dust from defunct satellites burning up in Earth's atmosphere could weaken our planet's magnetic field, a controversial new paper suggests. In the worst-case scenario, the unchecked expansion of commercial satellite megaconstellations orbiting our Earth, such as SpaceX's Starlink network, may generate enough magnetic dust to cut our planet's protective shield in half, potentially leading to satellite disasters and atmospheric stripping, the paper's authors told Life Science. But is the outcome really likely? Other researchers are skeptical of the paper's claims, that they all agree that one thing, there's an urgent need to quantify the scale of the problem. Private satellites currently in orbit are a rapid growing headache for astronomers due to their tendency to photobomb cosmic images and interfere with radio telescopes, as well as the increased risk of collisions with other spacecraft. But the real threat they pose may be what happens to them when they die. When spacecraft end their missions, most are deorbited and burn up in the Earth's atmosphere to minimize the amount of space junk circling our planet. However, as they fall apart in flames, the dying spacecraft litter our upper atmosphere with vaporized metal pollution. In the new theoretical paper, uploaded on the preprint database ARXIV in December 2023, but not yet peer-reviewed, Sierra Salter Hunt, a doctorate candidate at the University of Iceland, proposed that this atmospheric spacecraft dust may compromise the magnetosphere, the part of the Earth's magnetic field that extends into space and protects our atmosphere from solar radiation. Salter Hunt is concerned that if satellite megaconstellations evolve as planned, the amount of dust they release may create a magnetic shield that could limit the magnetosphere's reach. I was shocked at everything that I found and that nobody has been studying this, Salter Hunt told Life Science. I think it's really, really alarming, she said. We currently have no way of monitoring the amount of spacecraft dust in the atmosphere, but based on the amount of space junk that has already burned up in re-entry, we could have increased the amount of metallic particulate in the skies by 1 million-fold since the start of the space age, she said. And Salter Hunt estimates between 500,000 and 1 million private satellites could orbit our planet in the coming decades. When all these satellites eventually fall to Earth, it could dramatically increase the amount of spacecraft dust in the atmosphere to billions of times its current level, she said. It's currently unclear whether all of the spacecraft dust will eventually end up where it'll end up, but Salter Hunt thinks that it will probably settle in the upper part of the ionosphere, a region of the atmosphere between 50 and 400 miles above the surface, and she said it could just stay there forever. If all of these proposed satellites go up in flames, the resulting spacecraft dust could create a perfect conductive net around our planet and could be capable of carrying an electric charge, she said. If this happens, the magnetosphere, which normally extends thousands of miles into space, would be distorted to stay under the conducting material, essentially limiting its reach to the upper ionosphere, she said. A reduced magnetic field could expose satellites to high levels of radiation and solar storms which could knock them out of the sky. It's a real catch-22 for satellite companies, she said. They could be weakening the magnetosphere with what they're doing, which in turn puts themselves at risk. But even if the magnetosphere does not shrink, the increased levels of spacecraft dust could still make it harder for rockets to launch new satellites and other spacecraft into space. This is because the magnetic particles could interfere with onboard electronics, she said. In Salter Hunt's worst-case scenario, increased levels of radiation bombarding the upper ionosphere could begin to blow away the outer edges of our atmosphere, the phenomenon known as atmospheric stripping, which has naturally occurred on planets like Mars and Mercury. So that would be, of course, the end of our atmosphere. But this would be the most extreme case and may take centuries, if not millennia, to occur, she said. But even if the atmosphere remains intact, spacecraft dust could still damage it. Past studies have suggested that some of this pollution, particularly alumina, that's aluminum oxide, could deplete atmospheric ozone, potentially increasing the size of the ozone holes above Earth's polar regions. The magnetosphere is also undergoing some natural weakening as the Earth's core grows and solidifies, and nobody knows if spacecraft dust could accelerate this process. The important first step: some researchers praise the new paper for highlighting hidden potential issues of spacecraft dust. This work is a really important first step in highlighting the terrifying amount of spacecraft dust that could be deposited in the atmosphere, Samantha Lawler, an astronomer at University of Regina in Canada, said. The consequences of this pollution could also be on a totally different scale than we're used to thinking about, she said. However, other experts think that the scenarios laid out by Salter Hunt are too speculative or based on flawed assumptions. Even at the densities of spacecraft dust discussed, a continuous conductive shell like a true magnetic shield is unlikely, John Tarduno, planetary scientist and magnetosphere expert, University of Rochester, New York, said. Some of the assumptions in the paper are also too simple and unlikely to be correct, he said. In particular, no one has modeled how spacecraft dust will settle in the atmosphere, how long it will last, or how conductive it will be, meaning there is no proof that magnetic shielding is possible. Jose Ferreira, doctoral candidate, University of South California, who's also studying space dust pollution, said. The number of potential satellites orbiting Earth in the future also seems exaggerated, as many tooted satellite launches never occur. Elona Thompson, research fellow at Durham University in England, who specializes in space ethics, said, the paper is an interesting thought experiment, Thompson said, but without clearly outlining exactly how spacecraft dust will cause these problems, it should not be passed off as this is what's going to happen, she said. Salter Hunt understands the researchers' criticism. However, due to the imminent rise in satellite launches, she wanted to share her theories with the scientific community. She says, I could be totally wrong, but I put it there so everyone can see it and talk about it. And despite their reservations about this paper, the experts all agree that more research is urgently needed to study the possible effects of metal pollution in the atmosphere. And this is not an issue to be ignored, Thompson said. There is a need to step back and view this space junk pollution as a completely new phenomenon. There is a desperate need to study this as fast as possible, Lawler said. Honestly, I don't think anyone knows what could happen. This is by Harry Baker on Life Science. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.